Hi, welcome to my channel. In this video, we want to solve the following problem. AOB is a sector of a circle with center O, radius R, and central angle 120 degrees. Join A to B to form chord AB. Point C lies on arc AB, and point D lies on chord AB such that triangle BCD has sides 3, 4, and 5. The goal is to find R. And now for the solution. Since 3 square plus 4 square equals 5 square, by the converse of Pythagoras theorem, triangle BCD is a right triangle. With BC equals 5 as the hypotenuse, angle CDB equals 90 degrees. Next, let us use the law of cosines to calculate AB. Given a triangle with these dimensions, the law tells us that a squared equals b squared plus c squared minus 2bc cosine alpha. By the law of cosines in triangle AOB, ab squared equals r squared plus r squared minus 2r squared cosine 120 degrees. Since cosine 120 degrees equals minus 1 over 2, we get ab squared equals 3r squared. Therefore, AB equals square root 3R. Next, extend OB past O to point P such that PB is a diameter. The semicircle with diameter PB has radius R, same as the original sector. Join P to C and label the intersection of PC and AB as Q. Now, consider triangle BCP and the semicircle. Angle BCP is an angle inscribed in a semicircle. So by Thales theorem, angle BCP equals 90 degrees. Since PB is the diameter, PB equals 2R. Then by Pythagoras theorem in right triangle BCP, we have CP squared plus BC squared equals BP squared, or CP squared plus 5 squared equals 2R whole square. Thus, CP squared plus 25 equals 4R squared, which implies CP squared equals 4R squared minus 25. Therefore, CP equals square root 4R squared minus 25. Next, consider right triangle BCQ. Since angle BCQ and angle CDB are right angles, by the geometric mean theorem for altitudes, we have CD squared equals QD times BD, or 3 squared equals QD times 4. Therefore, QD equals 9 over 4. Then by Pythagoras theorem in right triangle CQD, we have CQ squared equals QD squared plus DC squared, or CQ squared equals 9 over 4 whole square plus 3 squared. And so, CQ squared equals 81 over 16 plus 9. Therefore, CQ squared equals 225 over 16. Taking the positive root, we get CQ equals 15 over 4. Next, consider intersecting chords AB and PC in the semicircle. QB equals 9 over 4 plus 4, which equals 25 over 4. Since AB equals square root 3R, AQ equals square root 3R minus 25 over 4. Similarly, since CP equals square root 4R squared minus 25, PQ equals square root 4R squared minus 25 minus 15 over 4. Next, let us apply the intersecting chords theorem. Given a circle with two intersecting chords, the theorem tells us that A times B equals C times D. By the intersecting chords theorem, we have 25 over 4 times square root 3R minus 25 over 4 equals 15 over 4 times square root 4R squared minus 25 minus 15 over 4. Expanding gives 25 square root 3 over 4R minus 625 over 16 equals 15 over 4 times square root 4r squared minus 25 minus 225 over 16, or 25 square root 3 over 4r minus 25 equals 15 over 4 times square root 4r squared minus 25. Multiplying both sides by 4 over 5 yields 5 square root 3r minus 20 equals 3 times square root 4r squared minus 25. Squaring both sides gives 75r squared minus 200 square root 3r plus 400 equals 36r squared minus 225. After combining like terms, we arrive at the quadratic equation 39r squared minus 200 square root 3r plus 625 equals 0. Using the quadratic formula, with a equals 39, b equals minus 200 square root 3, and c equals 625, gives two possible solutions. R1 equals 100 square root 3 plus 75 over 39, and R2 equals 100 square root 3 minus 75 over 39. To determine the correct value of R, let us return to the diagram. Since AQ equals square root 3R minus 25 over 4, we require square root 3R minus 25 over 4 to be positive. Square root 3R1 minus 25 over 4 is approximately 4.77, while square root 3R2 minus 25 over 4 is approximately minus 1.89. Therefore, R1 equals 100 square root 3 plus 75 over 39 is the answer. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.